right, so in this lesson, we're going to discuss what's called solution stoichiometry. So that is simply stoichiometry, just like what we've done before, but now using solutions, so using concentrations of reactants in order to figure out how much product will be formed and vice versa. So I'm going to show you 3 examples just to show you how this isn't actually anything that's really new. So for the first example, it says how many grams of silver chromate will precipitate when 100 mils of 0.400 molar silver nitrate solution is added to potassium chromate. All right, so silver chromate is one of my products. My 2 reactants are silver nitrate and potassium chromate. So I first have to write out the reaction here. So I start with silver nitrate. So silver, remember, has a +1 charge. Nitrate has a 1- charge. And so the formula for this first reactant is going to simply be AgNO3. All right, so that is going to react with potassium chromate. Now, potassium has a +1 charge, and chromate, CrO4, has a 2- charge. All right, so the formula for this reactant is going to be, when I cross my charges, K2CrO4. So this is going to be a double replacement reaction. Remember, we've got innies and we've got outies. So silver, which is an outie, will form a new compound with chromate. So silver, again, has a +1 charge, all right? And chromate has a 2- charge. And so the formula for this first product will simply be, once I cross my charges, Ag2CrO4. And then my other product is going to be potassium, K, which is an innie, crossed with nitrate. Potassium has a +1 charge, nitrate has a 1- charge, and so the formula for this is simply going to be KNO3. All right, and the last thing that I need to do is I need to balance. So I've got 2 potassiums here, only 1 potassium here, so I'm going to put a 2 in front. I've got 2 nitrates here, 1 nitrate on my reactant side, so I'm going to put a 2 in front there, 2 silvers, and I am balanced. So now it tells me I start off with 100 mils of 0.400 molar silver nitrate, and it wants to know how many grams of silver chromate will be formed. So I'm basically going to first need to figure out how many moles of silver nitrate I have, and then using stoichiometry, figure out how many moles of silver chromate that is. Using the moles of silver chromate, I then can get into grams of silver chromate. So I'm going to start off, and I'm going to use my concentration of silver nitrate as a conversion factor. So I'm going to start with 100 milliliters. Now keep in mind, since the units for molar are moles per liter, all right, I need to convert this into liters. So I'm going to do that by simply moving my decimal 3 places, 1, 2, 3, to the left. So my given here is going to be 0.1000 liters. All right, and I'm going to first get that into moles of silver nitrate by putting liters of silver nitrate on the bottom and moles of silver nitrate up top. All right, so I'm now in moles of silver nitrate. I don't want to be in moles of silver nitrate, however. I want to get into moles of silver chromate. So I'm going to put moles of silver nitrate on the bottom. All right, and I'm going to put moles of silver chromate up top. And that's the stoichiometry part of it. Okay. And for my last step, I'm now in moles of silver chromate, which is great, but the question isn't asking about moles of silver chromate. It is asking about grams of silver chromate. So I'm going to put moles of silver chromate on the bottom, and I'm going to put grams up top. And now I got to plug in my values. So here, this is the solution part of the solution stoichiometry. I need to put the concentration of silver nitrate. Well, the concentration is 0.400 moles for every 1 liter. Here I need to put the mole-to-mole ratio, that's the stoichiometry. So there's a 1 in front of silver chromate, a 2 in front of silver nitrate, and then I need to determine the molar mass of silver chromate. And in order to do that, I'm going to first take the molar mass of silver, which is 107.868, multiply that by 2, and then I'm going to add to that the molar mass of chromium, which is 51.996, and then I'm going to add to that the molar mass of oxygen, which is 15.999, and multiply that by 4. And the value that I get for the molar mass of silver chromate is 331 0.728. All right, so the mass of silver chromate that will be produced, that will precipitate, is 6.63456. If we look, 100.0 has 4 sig figs, 0.400 has 3 sig figs, so my final answer should have 3, so it'll be 6.63 grams. All right, let's look at the next problem. All right, for number 2, it says zinc reacts with hydrochloric acid to produce hydrogen gas and zinc chloride. How many liters of a 1.50 molar HCl solution completely reacts with 5.32 grams of zinc? All right, so for this problem, I'm already given the balanced reaction, and what it's wanting me to determine is the volume of HCl, and I'm given 5.32 grams of zinc. So what I'm going to need to do is I'm going to need to go from grams of zinc into, eventually, moles of HCl so that I can use this concentration in order to calculate liters, because I'm going to use my concentration as a conversion factor. So I'm going to start with 5.32 grams of zinc, and I need to get out of grams of zinc by putting grams of zinc on the bottom, and I'm going to put moles of zinc up top. All right, I'm going to keep going. I'm in moles of zinc, which is wonderful, but I don't want to be in moles of zinc. I want to be in moles of hydrochloric acid. So I'm going to put moles of zinc on the bottom, and I'm going to put moles of hydrochloric acid up top. All right, now that I'm in moles of hydrochloric acid, it's asking for liters. So I can put moles of hydrochloric acid on the bottom, and then I'm going to put liters of hydrochloric acid up top. All right, so let's look at this. The first thing, to go from grams of zinc to moles of zinc, I need to use the molar mass of zinc, which is 65.38. So I'm going to put 65.38 on the bottom here, all right, with a 1 on top. All right, that's the molar mass. Now I'm going to use the mole to mole ratio. I've got 1 mole of zinc for every 2 moles of HCl. And then to get into liters, moles per liter, that's simply the concentration of HCl, which was given to us as 1.50 moles for every 1 liter. All right, so really all of these problems are just manipulations of our units. All right, so I'm going to take 5.32, divide by 65.38, multiply by 2, and then divide by 1.50, and I get for my volume 0.10849. I want, let's figure out sig figs. 3 sig figs here, 3 sig figs here, so I want a total of 3 sig figs, so 0.108, and my units are liters. All right, let's try one more problem to practice. All right, so for the third example, how many milliliters of a 0.250 molar barium chloride solution are needed to react with 0.0325 liters of a 0.16 molar Na2SO4 sodium sulfate solution? So I know there's a lot of terminology here, but basically this is giving me all of the information I need to determine the number of moles of sodium sulfate I have. And then I need to use that in order to get into moles of barium chloride. Why do I need to do that? Because eventually I want to get into the volume or milliliters of barium chloride by using its concentration. So I'm going to start off with my volume of Na2SO4. So I've got 0.0325 liters of sodium sulfate, okay? And I'm going to get out of liters into moles by using the concentration. So I'm going to put liters of sodium sulfate on the bottom and moles of sodium sulfate on the top. Okay? I'm going to keep going though, because I want to get out of moles of sodium sulfate and into moles of barium chloride, which is what I am concerned about. So I'm going to put moles of sodium sulfate on the bottom, okay? And I'm going to put moles of barium chloride on the top. Now I'm in moles of barium chloride, which is great, but I don't want to be left in moles of barium chloride because I want to get into milliliters eventually. So I'm going to put moles of barium chloride on the bottom, okay? And I'm going to put liters on the top. Now I'm in liters. Don't want to be in liters. I want to be in milliliters. So I'm going to put liters on the bottom and milliliters on top. That was a very long conversion problem. However, we can do it. Moles per liter is my concentration, so 0.160 molar of Na2SO4 for every 1 liter. Then my mole to mole ratio here, I'm going to put a 1 in front here and a 1 in front here. All right, because those are my coefficients. Then I'm going to put the concentration of BaCl2, which is 0.250 moles for every 1 liter. And then finally, the relationship between mils and liters. 1 mil is 10 to the negative third liters. All right, so I'm going to take 0.0325. I'm going to multiply that by 0.16. Then I'm going to divide that by 0.250, which is the concentration of barium chloride, because the mole to mole ratio is 1 to 1. And then I'm going to divide that by 10 to the negative third. And so the volume that I get in milliliters, I want 3 sig figs from here, 3 sig figs from here, 3 sig figs from here. The value that I get is 20.8 milliliters. All right. And that's it. So looking back at all of these different problems, what you'll notice is that we're just adding one more conversion factor here, and that is your concentration. We've done the stoichiometry before. We've used your mole to mole ratio. We've used molar mass. Now we are using concentration in this stoichiometry effort.